Example 1, classification of quadrilaterals. In this example, I want you to name each quadrilateral, either parallelogram, rectangle, rhombus, or square, for which the statement is true. Some of these descriptions will have multiple answers. Take a moment, work this out yourself first, pause the video, and resume when you're ready to check your solution. Okay, equiangular. Equiangular shapes are going to be a rectangle and a square. In general, if any of your answers are rectangle or rhombus, square is automatically going to be another solution, because a square is a type of rectangle and a rhombus. All right, equiangular and equilateral. Well, equiangular is a rectangle and equilateral is a rhombus. Together, they form a square. Opposite sides are congruent. This is the definition of a parallelogram. If parallelogram is our answer, then so is a rhombus, because a rhombus is a type of parallelogram, a rectangle, and a square. Equilateral. Equilateral is a rhombus, which means square is also an option since square is a type of rhombus. Consecutive angles are congruent. If consecutive angles are congruent, that means actually that all angles are congruent. So this is equivalent to saying equiangular, in which case the answers are rectangle and then square, because square is a type of rectangle. All right, opposite angles are congruent. This is a property of a parallelogram, which means we also include the special three types of parallelograms: rhombus, rectangle, and square. Okay, this brings us to our next set of theorems. So if you're good with example 1, go ahead and move on to theorem 811, 812, and 813.